Ooh, that's on my email. All right, so this is the website. It's on the Moodle page. It's linked on the Moodle page. And it has a lot of different things that you can see. Let's see, the syllabus is right here. So one of the most important things for the syllabus is this calendar. And this calendar tells you when to come to class. You come to class when this calendar is blue. So you're here on the 10th. You'll be here again on the 14th. Next week on the 19th, the 24th. When it's orange, you will not be here, even if it's sort of one of your days, right? Because that's an exam day. And exams are all going to be proctored remotely. So you'll take your exams at home or in one of our computer labs here. You'll need a webcam and a microphone. I'll be watching you, but I'll be watching you from my office, okay? And is that creepy? It felt kind of creepy last semester when we did it, because people were like in their homes, and I was coming into their homes, and that was kind of weird. But I want to make sure that you have the utmost integrity. Your integrity, an exam is not worth your integrity. All right. On those off days, what you're going to be doing is filling in your notes. Zari, can you hold up your workbook? You have a workbook that looks like this. You can get it in the bookstore. Wait, sorry. It should have a picture of a guy doing like the high jump, like right here on the syllabus. They have 3 different workbooks in the bookstore, so make sure you have that one with the guy doing the backwards the high jump. In those off days, what you're going to be doing is filling in the notes on that. So on the website is right here. There's a link to online lectures, and hopefully most of you have already watched the Chapter 1 lectures and filled in the notes on that. I understand there are a couple of minor differences between what you have in your workbook and what's on the video. That's just because I made the video a bunch of years ago, and the workbook has changed a little bit. But we'll deal with those as we come up to them, and we'll see a couple changes today. So on those off days, you'll be catching up with the notes. Usually in this class, what we've done is you come in and we go over the notes together. You sort of write them down, and then we do practice problems. But now you're going to be doing that part outside of class, and in class we're just going to be doing practice problems. Okay? The other thing we're going to do is we're doing lots of quizzes and clicker questions. Or my syllabus. Here's my syllabus. So the other big thing that's important here are the different ways that I assess you. The first thing is class participation. And class participation is from your clickers. So y'all have brought clickers today? Yeah, we'll use them in just a little bit. If you don't have a clicker, that's okay. But make sure you bring your clicker on Friday, because on Friday, you know what's going to happen? We're going to have a quiz, and your quiz you'll take with your clickers. We're never going to exchange papers in this class. You'll click in your answers with your clicker. So your class participation comes purely from doing questions in class. I'll put a multiple choice question up on the screen. You'll answer that question. You can even talk about the answer with your neighbors or your friends, or you can call a friend on your phone or whatever. You can use whatever resource you need for those questions. You can even go through your workbook prior to coming to class and try to work out the questions beforehand if you like. That's not necessary, but you can. So when you answer those questions, you get a certain amount of credit. The way that I calculate your class participation credit is I say, what if somebody comes to class and they answer all the questions that I ask in class and they get them all wrong? That's the person that I want to get the full 50 points of class participation. The person that has come to every class and answered every question but has gotten them all wrong. Now, if you get answers right, I want you to get them right. When you get answers right, you get double the credit what you would otherwise. Okay? And since I max out your class participation at 50 points, that means that many of you, if you're getting, 2/3 of the questions right or half of the questions right, many of you will start to reach that 50-point limit sometime after exam 3. And I'll tell you about that. I just tell you that because it's not a big deal if you forget your clicker. It's not a big deal if you miss questions. It's not a big deal if you're out for a day or 2 days or whatever. At the end of the semester, almost everybody is going to have that full 50 points, except for people that are just chronically absent. Okay? All right. The other big thing is quizzes. You will have at least 6 in-class quizzes, but I'm only going to count 4 of those quizzes. That means I'm going to drop the 2 lowest quizzes, and I'll just count the top 4. I guarantee you 6 quizzes, but hopefully we'll get 7 or even 8 quizzes. okay? The quizzes will be in class. They're going to be frequent, and they'll be based on the old exams. Old exams are on that website. So this is really important. On the website where it says exam videos, if you haven't seen that, you need to see it today. Go there, and you can find every exam that I've ever given. They're all a little bit different, right? Every exam that I give, I write fresh and new. They're all really similar, too, because they're covering the same material. But for the quiz on Friday, for example, you'll probably want to go through these exam ones. I give you the last 3 years in your workbook, but I have all of them from the past, 11 years, 12 years on this site. Also on this site are video solutions. So if you click on one of these, you just find me working through the exams, okay? And so if you don't know how to work through a problem, you can just go to the video and you can figure out how to work it. If you still don't know, then you come see me and I'll help you. I'm always available to help you. Okie dokie? What are you going to do to prepare for Friday's quiz? Look at the old exams. In fact, the exams that I give you every semester are new and fresh. The questions are different from what you've seen on previous exams, but the quizzes, the questions are exactly from old exams. Okay, so if you practice with the old exams, I guess you could just memorize all the questions from all the old exams. That's probably 100 or more questions for each topic. But if you just practice them, you'll get a good feel for the questions. I'm hoping that Friday's quiz will be an easier quiz. I want you to start off with a good high grade, okay? But do some preparation for Chapter 1. And you can tell which questions are Chapter 1 just based on the topic. Is this estimation problem? Is it a trig problem? Is it a dimensional analysis problem? Okay. Go back to that syllabus. Find it. There it is. So quizzes. And then also extra credit. You can earn up to 20 points of extra credit by attending weekly help sessions. So we'll have a help session. I'll email you about it later. It'll probably be Friday at 2, but I'll email you about that later. That help session will likely be in this room, or it'll be in some other room in this building. And it'll be both face-to-face and virtual. Probably what I'm going to do for the virtual is not Zoom it, but instead I'll just, if you have questions, you can send them to me, and then I'll address them with students that are in the class, and I'll record that session, and you can watch it. You can take notes from it, take a snapshot of it with your phone and send it to me, and then you'll get credit for the help session. Or you can come. If you come, you don't have to send me a photo of your notes. I just write down so-and-so is here. Okay? Help sessions are useful. I feel like it just gives us extra time to practice together. I can really unpack some of your concerns and your difficulties in a closer setting, but then also you do get the extra credit as well. Want to be clear about that. The 20 points is not 20 percentage points. It's 20 points in the big pot. So in the big pot, you got 700 points. That's 4 exams, a final, that's 550. 50 for class participation, and then 100 points for your 4 quizzes that are 25 points each. So you have this big pot of 700 points, and then the 20 points goes on top of that. So percentage-wise, it's about 1 to 2 percentage points on your overall grade, which is still a lot, but it's not 20 points on your, you're not going to raise your grade 2 letter grades by the extra credit. Clear to you? All right. Here's a description of how to do the grading, makeup policy, academic honesty. If I get you cheating on an exam, which I will if you do that, or a quiz, you get a 0 flat out, and I'll report you to the academic dishonesty committee. Your integrity is really important to me. It should be really important to you. So, you know, don't mess around with it. Just know the material. You can know it. It's not that hard. Well, I say that's not that hard. It can be quite difficult, but with practice, every single one of you can do well in this class. I know that you can. There's the exam dates. You put those on your calendar. My office hours are here. I'm available pretty much. If I'm not in class, I'm almost always available. So just come see me if you have questions. You can arrange to come see me. That's my job, folks, is to help you. I know that seems strange, but that's my job. Like, that's what they pay me to do, is to help you do well in this class. So help me to do that. I want to do it. Okay, there are other things here. You can take a look at them on your own time, or we'll see them as we go through the course. Have any questions about the class? Yeah, Drake. Logan, I'm sorry, Logan.
So the quiz on Friday and all the little click questions, that's all going to be on Clicker, correct? You said that.
Yeah, so all of our quizzes will be clickers. They'll be, like I'll put the questions on the screen and you'll have 10 minutes or whatever to answer them. We're going to use self-paced polling for that. I'll show you how to do it on Friday. But all you need to know is just bring your clicker on Friday. We'll probably have it sort of towards the end of class, the quiz. I'll email you about that, Logan, everybody. Abby.
Yes, so on the help sessions, you said at like 2 o'clock we can come in here. Will you record them if we have like work? If we can't
Sure. Yeah, I know some of you have class or work, or you just, you have, I don't know, a party on Friday afternoon. So that's fine. I will record it, and it'll be on YouTube. There's actually a link here where it says help sessions. And it'll be listed here. So see, these are just help sessions from last spring. So that's 6th of December, 3rd of December. You watch it, you take notes, detailed notes, and then you take a screenshot of your notes and send them to me. Thanks, Abby. Other questions? This can be a difficult course. If you don't prepare for it, it can be difficult. It's not an easy course, but it doesn't have to be an impossible course. I know that you can do well on it. It's definitely doable to get an A. There is a link on the website from students that have made A's, and they give advice on how to make an A in this class. And really, they say come to class. They say practice the old exams and practice the notes and the clicker questions. All right. All right, let's begin. Well, we've been beginning, right? This is the equation sheet, by the way, at the front of your book. You'll have that for all of your quizzes and exams after we get to chapter 5. Really, chapters 1 through 4, there may be 4 or 5 equations that you need, and I just want you to memorize those. But once we get into chapter 5, there come to be more and more equations, so I give you an equation sheet. All right, so chapter 1. I'm not going to go through these notes. Hopefully you've already watched the videos and you've learned things about the standards of length, mass, and time, about what the standard for length is. That's a meter, and the standard for the meter is based on the speed of light. Some of you have already watched that, is that correct? Okay, good. I know that you aren't really started, but I wanted you to get a head start just to keep our schedule. So one thing that has changed from the video, I'm pretty sure this wasn't in the video, because we didn't know what it was back in 2012 or 13 when I made the video, is what is the standard for the mass measurement. So the current unit of measurement for mass, you probably already have this, I'm going to write it, is the kilogram. And the standard for the kilogram used to be a cylinder in France. Like it was an actual metal cylinder. Platinum, I think, platinum iridium cylinder that was about yay big, and it had a mass of 1 kilogram, which is about that big. But the problem with this cylinder in France is that it was losing mass. So if they plot the mass versus time of this cylinder, they actually had multiple copies of it, they would find that some of the copies would be gaining mass, some of them would be losing mass, some of them will be doing it at different paces. The point is that it's losing mass or it's changing its mass. So if you have a standard that's changing mass, that's very, very bad. That means that your definition of a kilogram is changing as time goes on. And so what they've done just in the past year is to create a new standard for the kilogram. And the new standard is based on Planck's constant. That's an important word that you'll need to know. Planck's constant, that the standard for mass is based on Planck's constant. Some of you might have seen Planck's constant before in high school chemistry. It came up in this equation, that the energy of a photon is proportional to the frequency by Planck's constant. So Planck's constant is this variable right here. You don't need to know that equation. I just want to draw a little context there. And the way that they measure this standard for mass is something called a Watt balance. To define the standard. And a Watt balance, well, it's just a balance. Some of you might have seen balances that look like that, like the scales of justice kind of thing. It's a balance that really, it works a lot, it looks a lot like that, except it's just a little more complicated. It measures currents and it relates the mass to the current, and then it bases it on Planck's constant. So really two words there that I want you to know: the Watt balance and Planck's constant as related to the kilogram. If you sort of keep those words in your mind, those key words, that'll help you to remember what the new standard is based on. Okay, so now our standards are based on the speed of light for the meter, Planck's constant for the kilogram, and the frequency of an oscillating cesium atom for time. You need to know those. You also need to know what makes a good standard. And I have a question here about those. So these notes, you can go through and make those up or get those on Wednesday or as the week goes on. But right now, let's try this quick test question. By the way, you should be on AA frequency. If you need to change the frequency of your clicker, you hold the power button down, and then you do AA. It's usually the default for your clickers, so if you haven't changed it, it's probably on AA frequency. All right, so let's try this question. Which of these is a reason that a standard of measurement is not appropriate? So which of these are true? If these are true, would be a reason that a standard is not appropriate. I love these questions, by the way. Get used to them, where I give you a list of statements, and you have to pick which statements are true or false. And sometimes more than one might be true. You can ask your neighbor what they put. I encourage you to, in fact. All right, we're sort of all over the board on this. Feel free to ask your neighbor, and we will stop at about 125. 125, let's stop there. It's not a huge deal if you get all these questions wrong, except that this is a good time for you to just be thinking about what's on the test. So it'll help to prepare you for the test. All right, I think E is the right answer. For standards to be good standards, they need to be accurate. They need to be accessible to just normal people like you and me, and they need to be unchanging. Those are the three properties of standards that we'll look at to make a good standard. So if a standard changes, that would mean that it's not appropriate. So one is a true statement, or it's the reason that a standard would not be a good standard. If it's not available, that means it's not accessible to everyone. So that little artifact, that little kilogram that they had in France, not accessible to everyone. It was under lock and key. Not just anybody could go in and see it. So if you wanted to know what a kilogram was, you had to know somebody to know what a kilogram was. Can it be based on some obscure physical constant? Planck's constant, I mean, it's kind of a common constant. Speed of light, frequency of the cesium atom, you might argue those are obscure. So it doesn't matter if it's some obscure physical constant. And it definitely doesn't matter if it smells really bad. But I don't think any of the standards smell bad. Does the speed of light smell bad? It does? No. Okay, so E is the right answer. Accurate, accessible, and unchanging. You'll have questions like this. You'll probably have one or two questions on the exam that are about standards of measurement. I'll ask you to identify the different standards of measurement, and I'll ask you a question like this likely. You know your metric prefixes, know how to go between the different metric prefixes. All right. Dimensional analysis, I think I had these questions in your notes, right? I did these. Well, let's try this question. Is this equation dimensionally correct or not? I need to make a little correction here. This should be meters over second. So over here, I give you the units of these variables. If you don't know them, just let me give you a hint too. In this equation, there are some variables that you can cancel out. So for example, I can cancel out these two a's right there. And it makes the problem a lot easier if I do that. There might be other variables you can cancel out as well. Right now, y'all split sort of half and half, which is exactly what the other class had. All right, let's stop at 140. 140. I don't have it right. All right, that's good. All right, 140, I'm going to stop. Very good. A is right. Hey, do you know what happens if you get above 90%? You get a joke. Top of the shelf joke. Really funny. I usually be falling on out of your chair. It's so funny. All right, so let's work on that. I want to see you do better on these. All right, so I can cancel out some other variables, like these m's, which are for mass. I can cancel out those, right? I can also cancel out one of these v's right here. I can also get rid of the half, because a half is just a constant. It doesn't have any units attached to it. And so now all I'm left with is x over t is equal to v. And the way I tell if it's dimensionally correct or not is I put in the units for each. So v is meters per second, x is meters, and t is seconds. And so since both sides are the same, this is a dimensionally correct equation. Dimensional analysis can be kind of important. One, it makes your algebra skills a little stronger. And also physicists and scientists in general, that often if they have an equation, they don't really think about is the equation, well, they think about is it correct or not. But often the first step is just looking, do the units work out right? And if the units work out right, then there's a pretty good chance that you have the equation right. If they're wrong, it's definitely not right at all. Okay, there are other questions that you should practice from the old exams, and we might see another one today, we'll see. All right, sig figs. So you probably know sig figs, so let's just jump right to some of the practice questions. When you're multiplying numbers, you keep the lowest number of sig figs. When you're adding numbers, you keep the lowest number of decimal places. We'll do sig figs in the lab too. We'll do it actually in the first online lab. So let's try this question. I have this operation, and I want to know what is the final answer. If you put this in your calculator, you get 0.002941. And I want to know what is the appropriate answer keeping proper sig figs. All right, let's stop at about 110, 115 maybe. We'll go to 115. All right. Looks like mostly y'all are split between A or B. 115, I'm stopping. Okay. Okay, let's see. I think, yeah, the answer is A. I can tell that because the first thing I want to do is this operation up top. And if I do that, this has 2 sig figs, but this just has 1 sig fig. Like both of these are significant, and this one is the only one that's significant. So when I multiply that, I just get 0.01. I just keep one significant figure divided by 3.4. And so here I have 2 sig figs in the top and 2 in the bottom, so I should have 2 in the final answer. So what y'all put B? Oh, no, y'all put A. I'm sorry. It is A. I have 1 sig fig here, 2 in the bottom, and so the final answer should be not B, but A. Okay? Y'all good with that? Now let's try this one. This one's a little bit more difficult. With this one, how many sig figs should the final answer have? And you might want to just work this out. You don't need your calculator, I don't think, to do this. Once you see it, you'll see that the numbers aren't complicated. When you add numbers, you keep the lowest number of decimal places. When you multiply, you keep the lowest number of significant figures. All right, well, let's stop at 110. 110. So if I do the top part, the 4.1 plus 0.920, what is that answer? What is that going to be? If I just do this first operation, the 4.1 plus 0.920. I'm keeping the lowest number of decimal places, so it's going to be what? Is it going to be 5.020? No, it's going to be what? How many decimal places will I keep? Just 1 decimal place. So this would just be 5.0 squared divided by 2.54. And now I would keep, see, I just kept 1 decimal place. Here I had 3, here I had 1, so I just kept 1 decimal place. And now I go through the multiplication. Right, I'm going to stop this, 158. Okay, and then this would be 25 divided by 2.54. And then if I do that, I get, what's that, 10. But I have two significant figures. So when I have a digit like this that has a 0 at the end, the way that I show that that 0 is significant is I put a decimal point right here. That's the way I'll do it, although this doesn't happen very often. Or you can put like a bar over the top. I've seen people do that, but I always just put a decimal point, and that tells you that both of these digits are significant. Okay? You'll have 1 or 2 questions about significant figures, probably 2. One will be just, I'll give you some number and ask you how many sig figs are in it, and then the other problem will be sort of like this, where I give you an operation, mathematical operation, and ask you what the answer is or how many sig figs should be in the answer. Okay. Let's do unit conversion. This is also really important. It's a lot. Actually, no, I don't think I have any questions about this. But we'll see questions that are related to unit conversion later. Make sure you go through this in your notes and you get this. All right, this part of the workbook was a little bit different from what you had. So let's go over this. Estimations, I feel like they should be simple, but students often struggle with estimations. And I think part of it's because you sort of live in the British system. You live using pounds and feet. And I'm asking you to use something like meters or kilograms or centimeters or millimeters. So I want you to know what these different measurements are. Do y'all have this part where it says 1 meter, 1 centimeter? Do you have that in the video? Yeah, that part was in there, right? That a meter is about 3 feet. It's about this long. All right, it's just these questions. What is the volume of this room? What is the mass of your head? And what is the area of your desktop? Those are good questions for the exam. I would ask you something like that. Estimate the volume of this room. So let's try to estimate the volume of this room. First of all, if you look at the tiles, how big are they roughly? They're about a meter. In fact, I think they're a yard, that they're a yard square, which is about a meter. So they're about 3 feet across and 3 feet deep. So if I just count the squares, the front of this room is about 10 meters wide. So I have a room that's 10 meters on this side. How deep would you say it is? If this is 10 meters, what is this? 20. Let's just say 20. It's roughly twice. I'm not looking for accurate. It's an order of magnitude estimate. I just want an estimate. And then how tall is this room? In meters. 5 meters. Well, 5 meters would be 15 feet. So I'm about 2 meters tall. So you add another meter on top of that, it's going to be about 3 meters tall. So let's see if I can draw this. You get the idea. So that's 3 meters. And so if I want to know the volume of this room, it would be 3 times 10, which is 30, times 20, which would be 600 cubic meters. So on a test, how I pose that to you is I say, what is the volume of this room? And I would give you answers like this: 6, 60, 600, 6,000, and maybe 60,000 cubic meters. And you would have to pick out the answer. It wouldn't always be in the center. It might be the smallest number or the largest number, but you would have to pick out which it is. This room is definitely not 60 cubic meters, because 60 cubic meters is like here behind me, 1/10 the size of this room. And it's definitely not 6,000 cubic meters, because that would be a room 10 times the size of this room. That's what I say that's what I mean when I say order of magnitude, to the nearest factor of 10. So if you have an idea of what a meter is, and you know how to estimate the volume of a space, then it should be obvious to you. You might not get 600, you might get 800, but it's not 6,000 and it's not 60. You just sort of pick the closest number for an order of magnitude estimate. The mass of your head, I have an idea how heavy your head is, or what is the mass of your head. Now, I might give you options that would look like this, say 5 kilograms, 50 kilograms, 500 kilograms, or 5,000 kilograms. And what would you say would be the answer? It would be 5. A typical person weighs about 70 kilograms or has a mass of about 70 kilograms. And so you know it's not 50 unless you have like a huge head, like an orange on a toothpick. Do y'all get that reference? You get it? Y'all seen that movie? An orange on a toothpick from So I Married an Axe Murderer. Y'all seen that movie? It's hilarious. You should watch it. It's very funny. It has, what's that guy that was in Wayne's World? And Austin Powers. What's that guy? Who? Myers? Yeah, that guy is in it. It was like one of his early movies. Y'all should watch. I think it's from the 80s or maybe early 90s. Okay, so that's the mass of your head, would be 5 kilograms. And then the area of your desktop, I would probably ask you that in square centimeters. A centimeter is about the width of your pinky. It's 1/100th of a meter. And so you could estimate the area of your desktop. I might say that that desktop is, I don't know, 30 centimeters wide, 30 centimeters, and 20 centimeters deep. And so that would be about 600 square centimeters. And then I would give you, 60, 600, 6,000, 60,000 square centimeters. You'd have to pick out the right answer. Let's try one. Let's try this next one, where I ask you, what is the area of this projection screen? And actually, when I wrote this question, I intended it for Pelcha Auditorium, which has a much bigger projection screen, but it'll work for this. Tell me, what is the area of this projection screen? Is it 1 square meter, 10 square meters, 100 square meters, or 1,000 square meters? Remember, you get a joke if you get above 90%. Feel free to ask your neighbors what they put. I think everybody, well, almost everybody has it right now. All right, let's stop at 45. 45. Awesome. B is the right answer. That's exactly what the 3M class got. They got 89%. So the area of the projection screen, it's definitely not 1 square meter. That's like the area of one of these tiles. And it's definitely not 100 square meters, because that would be this room, like this wide and that wide again. It'd be like a big movie theater screen. So the answer is somewhere in between, about 10 square meters. Hey, what's the worst thing about living on O Street? Listen, I'll tell you a lot of jokes this semester. So when I tell you a joke, you don't try to answer the question. No, you don't do that. That's bad joke etiquette. When I say, what's the worst thing about living on O Street? You just say, I don't know. You have a very easy job. You say, I don't know. I don't know. You got to walk a whole block to pee. You can use that one on your own if you like. All right, let's do a little trig. We're almost done. Let's try this quick test. So this is a coordinate a coordinate in space. These are the XY coordinates, but I want to express them in the plane polar coordinate system. And that just means that I want to know this distance. That's the first question. Notice this is a triangle. And then the second question is I want to know what is this angle. Well, let's answer that first question first. What is R? What is the value for R? For trigonometry, you really only need 2 things. You need to know the Pythagorean theorem, and you need to know SOHCAHTOA. You need to know your trig functions. Let's keep our mask on all the way to class. Thank you. If you finish this one, you can go and look at the next one. And I'll put it up on the clicker. So write it right away. All right, let's stop at 135. 135. Okay, good. B is the right answer, 4.3. The way you do this is you would say, well, I have a triangle right here that has this side is 3.5 and this side is 2.5. And to find R would be equal to 2.5 squared plus 3.5 squared. That's from the Pythagorean theorem that says A, B, C, that's my triangle, A squared plus B squared equals C squared. So that R is equal to 4.3. You need to know the Pythagorean theorem backwards and forwards. Like you need to know how to use it. And you really need to not think about it that much. Okay? So need to know how to calculate this. In fact, I'd really love you just to look at a triangle and say, well, I know that hypotenuse is not 19 meters. That's just crazy. I think it's probably not 6 meters. It's probably going to be 4.3 meters, just from looking at the sides 3.5, 2.5. Let's try the next question where I ask you this angle theta right here. Is it 324, 36? Or what was the other one? 216. All right, what is the angle theta? And to do this, you need to use your trig functions, or just try looking at it. You might be able to reason out what the answer is just from looking at it. often on my tests, that's always an option that you can sometimes just look at a problem, often look at a problem and not have to write down anything or not have to calculate anything, and you might be able to reason out the answer, or at least get rid of some bad answers. Okay, doing well. So a couple more seconds. I'll stop at 43. 43. Okay, good. C is the right answer. I can say that it's C right away because it's in which quadrant? R. It's in the third quadrant. Know your quadrants. They will help you. 1, 2, 3, and 4. And the third quadrant is somewhere between 180 and 270 degrees. And so that would limit me just to 216. But if I really want to find what that angle is, let's say I would first find this angle. Phi is the inverse tan, let's see, SOHCAHTOA, opposite over adjacent, 2.5 over 3.5. That's the opposite side over the adjacent side. And then I would find that that's equal to 36 degrees. But it's not 36. That's not the answer because I have to add the 180. So 180 plus 36 is equal to 216. Okay? You'll have just a basic trig question, but then it comes up a lot in other questions that we'll do in this test and just going forward. All right, folks? It makes me cringe